Hey everyone, welcome back to the channel. Today I'm super excited to show you something a little different but really useful. I built a chat interface powered by local AI models using Ollama and Streamlit. I am calling it Chatlama, which is chat plus Ollama. It is a lightweight local AI tool where you can interact with LLMs like Llama 3, Mr. Gemma, and load Word documents and ask questions, all in a clean and simple UI. And the cool thing is, you can run it completely on a local machine. You don't need any API keys or anything like that. Let me share the demo first. So here is the app. On the left, we have a sidebar where you can select your locally installed Ollama model. If no models are available, the app gives you a friendly error telling you to install one first. Once a model is selected, you can interact with that model and ask questions. You can also upload Word document file and type your questions, and the model will give you a response based on the document. To use this app, you should install Ollama and the models that you want to test. Here I am selecting the model Tiny Llama and asking what is machine learning. You can see it gathering information from the model. It gives a pretty good answer with details like some common use cases as well. On the left sidebar, we can see the response time for each question for the selected model. I am going to switch the model to Gemma and asking the same question to that model. Let us check how it gives the answer. It gives a more detailed answer compared to the Llama model. It gives the definition, how it works, type of machine learning, benefits, and a few examples as well. Here, the accuracy and information detail is improved when comparing the Tiny Llama model. But the response time is a bit higher compared to earlier. It is obvious because we are using a model with higher parameters. So we can expect that, and also my hardware setup is not much upgraded. Let me try with another model, which is DeepSeek R1 1.5b. Here we got a more structured answer with type of machine learning, key algorithm, etc. I think this is more structured compared to the earlier models. You can also see the response time for this model as well. Now we can try the RAG system that was added in the application. For that, I am going to upload a document from my system. This is a Word document that contains a product manual, basically a demo product. This document contains a sample product called Smart Air Purifier 3000. Basically, it contains details about the product and usage of the product. So I am going to ask how to use Smart Air Purifier 3000. As you can see, the response that we got from the LLM, and it is based on the document. When you compare the response with the document, it is pretty good response and well structured. Here, the response time is higher because it gathers information from the vector database and then pass to the LLM. If you try with another model like DeepSeek, we will get a valid response based on the document context. You can try with different models. The structure of the response and accuracy may differ according to selected model. In this application, we are also saving the chat history as well. Now we can look into the implementation and how we can run this application locally. First, let me go through the code and explain the implementation. This app uses Streamlit for the UI, Ollama to generate responses, PSUtil to fetch system info, and Python docx to extract content from the uploaded Word files. In the RAG system, we upload a Word document. It extracts and split the text, convert into embeddings using sentence transformers, store embeddings in FAISS for fast retrieval. Use Ollama models locally to answer questions based on the document context. We use multiple libraries here. Streamlit to create the user interface, Python docx to read the document files, Ollama, which is a Python SDK to interact with Ollama LLMs. It sends prompts to local models like Mistral, Llama, etc. Temp file creates temporary files. docx to text loader. It loads and extracts content from Word document in a LangChain format. It transforms the uploaded file into LangChain document object, which is useful for text splitting and vectorizing. Recursive character text splitter. It splits large documents into smaller chunks. Sentence transformers from Hugging Face. It turns text into numerical vectors. Here we use all-mini-LM L6v2 model for vector embedding. FAISS library. It is a Facebook AI similarity search library. It is efficient for vector similarity search. The function getLocalOllama models. It connects to your local Ollama server running on localhost 11434 and gets a list of all available models that are installed and ready to use. The chat with model function sends a user prompt to a locally running Ollama language model, receives the model's response and returns both the generated text and the time taken to produce it. It starts with recording the current time, then uses ollama.generate to query the specified model with the prompt and options like temperature and max token limit. After receiving the response, it calculates the duration and returns the model's output along with the response time. If you upload the document, the system uses the RAG to fetch information based on the document. This RAG workflow is basically, once you upload the document, it saves the vector embedding in the FAISS vector database using the document content. And when the user asks a question, that question is also converted to vector embedding and searches for similar vector embedding in the FAISS vector database. Once it gets similar data, it returns that data. Using this data plus the user query is passed to the LLM to get the answer. That's how the RAG works here. I already created multiple videos explaining how this RAG works, including the code explanation. You can check it out. Now let us look how we can install this application. Before installing the application, make sure you have installed Ollama in your system. To install Ollama, go to their official website and download the application and install it. Once it is installed, you can pull the models and run them in your local systems. You can find the supported models in the Ollama library. You can also find the commands to pull the corresponding models. Once you are done with Ollama and model installation, now we can install our application. First, you need to clone this repository. Then change directory to Chatlama. Then enable a virtual environment. This is optional, but I highly recommend you to use a virtual environment. Then use this command, which is pip install, to install all the required libraries from requirements.txt file. Once it is completed, run Streamlit, run app.py to run this application. So that's it. You can see the web UI and you can select the model and interact with the models. I will share the script and full details in the description box. You can try it and let me know your comments. This application will be really helpful to find the accuracy of the Ollama models. And also, we can check the response time for each model. This will help you to select the model according to your requirement. Also, we can check the accuracy of this RAG system for each model. So that's all about today's video. If you found this really helpful, please consider to subscribe the channel and like the video. Thank you for watching and see you in the next video. Bye.